then we can go further for MOSFET technology. Why MOSFET? Because the mainstream IC industry focus on most metal oxide semiconductor field effect transistor very much. That is the key component for nowadays IC industry. But you can see from the very beginning, this is the first MOSFET transistor actually was created in two different places, Canada in 1925 and England in 1935. Anyway, that is the very brief idea, very rough idea. It is no good for mass fabrication. So after 35 or 25 years, humankind created the first CMOS. C means complementary. It means it has not only NMOS but also PMOS. However, we still had a lot of trouble with manufacturing. So, for realization, we had PMOS first. For calculators, as I show you, Casio, blah, blah, blah. Okay? But why PMOS? Because PMOS comparatively is with lower power than NMOS. All right? But if you would like to speed up the operation, you need NMOS. According to mobility, mu n, I think 2.5 or 3 times larger than mu p. Okay, so with the same size, NMOS can operate 2.5 to 3 times higher than PMOS. So if you are speed lover, then you need to go for NMOS 10 years later. And this is from Intel. Okay, finally, 20 years after the creation, humankind finally figure out how to produce such kind of device massively. So in 1980s, CMOS finally went to the commercial market. But why? If you compare CMOS with NMOS, NMOS can still operate with higher speed than CMOS. But why? We would like to go for CMOS instead of NMOS, or even BJT can operate with much higher speed. Why not BJT? The simplest issue is still power consumption. Okay, if you would like to reduce the power, then CMOS till now is the best solution among all those processes. And for the others, if you would like to get better speed, for example, by CMOS. By CMOS means what? BJT and CMOS. Okay, in addition to CMOS process, they can also help you to have such kind of BJT to speed up the operation for main circuit, for critical circuit. Or if you would like to get rid of such kind of silicon-based processes, based on silicon, right? 细制成. You can go for gallium arsenide or silicon germanium, blah, blah, blah. All of them can operate with higher speed than CMOS. However, humankind wouldn't like to go for that market, only for very special purpose applications. Otherwise, we simply forget about all of them. Why? First of all, power, too much power consumption, and then much more expensive than CMOS. Okay? The main reason why CMOS can defeat all of the others simply because it can provide less power consumption, and it is much cheaper. That is the key. Okay, less power consumption, cheaper, much cheaper. Make CMOS the king for all those processes. All right, and for new evolution, for CMOS, we have from the beginning bulk process. It means we fabricate all the transistors, all the devices into or on the substrate. That's it. Okay, and how about that is what we call bulk process. TSMC, UMC, the process is actually originated from American company called RCA. Yeah, this bad company pollute Taiwanese land very much for monitor production. Yeah, it is a bad guy. Anyway, we learn everything from RCA for 2-micron process, to my memory. Okay, that is the first company copied and pasted from RCA to Taiwan is UMC, Liandian. Okay, and then the second company is TSMC. Morris Zhang Zhongmo, yeah, was invited from TI. At that era, he was one of the vice president for TI. He was invited to Taiwan, yeah, to help us run TSMC. Yeah, Morris Zhang thought, oh, if TSMC did the same business as UMC's, then those two companies need to compete with each other. It doesn't make any sense. So Morris Zhang created a brand new idea for chip fabrication. Okay, in the past, including EMC, all the companies, they were IDM. It means they design and fabricate everything by themselves. So Morris Zhang made his mind to make TSMC only for fabrication. TSMC wouldn't like to design anything because he hoped with such kind of strategy, TSMC won't be possible to compete with its customers. Okay? With such kind of strategy, he would like to gain the trust from all the other companies to have their chips fabricated by TSMC. Actually, the strategy is totally different, not only from UMC, but also from Samsung. Samsung right now is still some kind of IDM big company, mega company. Yeah, it fabricates everything, the LCD, OLED, and DRAM, flash, mobile phone, everything by itself. Okay, but it also helps the others, Apple, just like Apple, from A4 to my memory. Okay, all the way to A8. Before A8, all the chips of Apple were fabricated by Samsung. But the trouble is, Samsung fabricate Apple's chip and also design its own chip, fabricated its own chip for its own mobile phone, right? So what is the secret? The design team just had a look at Apple's design, then stop the whole design, okay, to duplicate everything from Apple. 3 months later, yeah, their new Android phone was fabricated with much similarity to iPhone. Yeah, not only the appearance, but also the inside core, exactly the same as Apple. Okay, so Apple sued Samsung, and finally Samsung was fined for $1 billion US, 10 亿美金, but it means nothing. Okay, because by copying Apple's design, I guess Samsung made more than 100 or even 1,000 billions US dollars since after. Yeah. So till now, Apple wouldn't like to go back Samsung for chip fabrication. Yeah. One of the main issues is it is unsafe to ask help from your enemy to fabricate something for you. Yeah. Just like USA, it wouldn't like China to help USA fabricate some kind of military chips. Otherwise, all the secrets for their weapons will be released to China. And this is the reason why Donald Trump forced TSMC to open another branch. Right now, TSMC has one branch in USA, but with a not so good process. Okay, so for the best process, I mean 5 nanometer, TSMC was forced to agree to fabricate chips in 5 nanometers in USA 2 years later, to my memory. Okay, and will it come true? Let's wait and see. If Donald Trump is elected again, then okay, yeah, TSMC has better to go. If not, then he will wait and see what will happen. Okay, let's go for the first commercial chip from Fairchild, 1961. This is the microphoto. Oh, actually, yeah, you can see this is chip size, the width, the length, and it had 2 flip-flops with only 4 transistors. Then, 2 years later, the second version, you can see the circuit has 4 flip-flops. From the beginning, only 2. Right now, it is doubled. But the size is reduced. Can you see? The tendency for scaling down is never ended since those 2 chips. Okay, from the very beginning, you can see more devices and less chip area. That is our dream. And it will be never ended. 我们会持续的把它给萎缩下去。So you can see from the beginning, 1961, 10 years later, microprocessor, 微处理器. It is designed by Intel, to my memory. Yeah. Oh, you can see it had already 1,000 transistors. From the beginning, only 4 transistors, 2 flip-flops, 4 transistors. Right now, the number is 250 times more after 10 years of evolution. Okay? Wow, bingo. You can see 2000, Intel Pentium 4. It had already 42 million. Wow. 4,200万. From 1,000. So, if you go further 2 years ago, Apple A12, you can see in TSMC 7 nanometer process, 8 colors, blah, 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 and totally, wow, from million all the way to billion. Okay? 6.9. Wow. That is only 2 years ago. And how about today? Oh, I promise you, much more than this. Okay? So sooner or later, we will touch the boundary of trillion. Okay, let's wait and see how soon it will be true. Okay, so there was a guy called Gordon Moore. he was one of the co-founders for Intel. Yeah. After 4 years of the creation for the first chip, after 4 years watching, he created an ambitious law for IC industry. He said, he pointed out the number of transistors on a single chip will be doubled every 1.5 to 2 years. That is his prediction. That is his prediction, his very ambitious prediction. And humankind followed his prediction for more than 40 years to 2000 something. But why? Oh, simply because he's the co-founder of Intel, and Intel till now is still the top one IC company on earth. Okay, so I guess, by purpose, 故意的, okay, Intel follows the prediction of one of his co-founders. Yeah, that's it. No secret. But till now, I think it's really hard to achieve such kind of prediction, to follow the prediction, because our transistors becomes too small. It's even harder than before to scale it down. Okay? So what do we do? If you cannot follow it two-dimensionally, then according to X and Y, too much, okay? Then we need to pile it up to become 3D. So roughly speaking, humankind still follow the prediction of Golden Moore. It becomes a golden rule for IC fabrication, for IC industry. And it makes Golden Moore very famous in this industry. Not because he designed something, he created something brand new, help our human life very much. No, only with such kind of silly prediction. Yeah, but please keep this in mind. It is really important. That is the tendency, the main trend of our dream for scaling down. For 1.5 to 2 years, we need to double the number of transistors on a single chip. Okay? Never mind how hard it is. In the past, Intel helped us to realize it. But nowadays, Intel had a trouble issue, a big problem with its fabrication. Right now, it is stopped at 10 nanometers. But I need to point out that for performance, because the definition for Intel is different from that of TSMC and Samsung. Okay? So Intel's 10 nanometer in performance is about equivalent to 7 nanometer of TSMC or Samsung. All right? So it has a big problem. Because right now, TSMC has some kind of mass production for 5 nanometers already. Maybe next year, 3 nanometers will go for mass production. So there is a big gap between Intel and TSMC. And it is heard that Intel may get help from TSMC to fabricate not only GPU, maybe also its CPU. Okay? If it is true, our world will change a lot. The top one company on earth, Intel, I guess it will become top 2. Yeah. Sooner or later, it needs to get rid of its own fabrication department. 他必须把生产部门砍掉。Okay. The size of the company will be scaled down very much, just like AMD. AMD in the past designed and fabricated its own chip. And finally, it figured out it didn't work in this way. So it separated from the help of IBM and Abu Dhabi investment agency or something. Abu Dhabi 投资局 or something, yeah, to separate it. To separate its own fabrication department to be a brand new company called Global Foundry. Okay, but Global Foundry maybe 2 years ago announced that it was stopped at 14, even earlier than Intel. No more. Global Foundry, UMC, all the others, they didn't have enough money to invest for newer processes, just like they were mentioned about 75302. No. Okay. For all the others, they stop here. And AMD got the chance to pay 3 billion something, 3.5 billion. Okay. 350亿，哦不35亿，35亿美金 to Global Foundry, and then enough means enough. Since after, I wouldn't like you to help me fabricate anything. I would change my mind, turn my head to TSMC, and after that, the market share of AMD, rose exponentially, and Intel got a lot of stress because its process is stopped here. The yield, 良率, was really low for such kind of 10 nanometer, even till now. Okay? Is GPU actually with the same technology? I think it is better than AMD. But AMD get much better process from TSMC. Right? Even the technology for AMD is worse than Intel. But who cares? With better process, AMD can compensate for its poorer technology. So on average, AMD can provide about the same performance or a little bit better performance than Intel, but maybe 20 or 30% off in price. And how about us? I mean, customers. We go for such kind of cheaper and better chips. That's it. Okay. So you can see the evolution of DRAM. Well, about the same as the prediction of Golden Moore. Yeah, it grows almost 4 times for every 3 years. So 2 times for 1.5 years. It makes sense, right? Yeah, but how? Let me say, hey, does it relevant to our humankind? Yes, because you can see from the very beginning, one chip can help you hold 1 page of information. Okay, so here, 1 book, your analog IC design. The textbook can be stored into 1 chip here. Yeah, 1990s. And then, the whole encyclopedia, 百科全书, all of them can be stored on the same chip. Whoa, you can see the capacity was increased a lot from the past. Okay? So even in 2010, we can install our whole humankind memory, our DNA, the whole DNA sequence, into a single chip. It opens another dream for humankind. Okay? Hopefully, our life, not only our dream, but also our life will be never ended in the future. Yeah. Not physically, I mean mentally. Before passing away, we can store all our intelligence, our knowledge, our know-how into the chip, right? Or you can go to the street to get some young guy, healthy young guy, right? Then transfer all your information to the chip and then to the young guy. He will become you. You can live, yeah, just like a god. Hitler, okay. Oh, so that is the reason why the closer to our dream, the more dangerous it becomes. Hopefully, nothing will go wrong in the future, hopefully. And you can see the transistor count, the number of transistors on the same chip. Oh, yeah, you can see. Yeah, from Intel, by purpose, it follows the prediction of Golden Ball. Yeah. Anyway, anyhow. Oh, ooh, allow me to show you another very good figure. Even 2 years ago, for Xilinx FPGA, on a single FPGA chip, it had 50 billions. Oh gosh, even more than Apple. Okay, so as I mentioned, sooner or later, we'll break through the barrier of billion into trillion. Wow. And how about the microprocessor? About the same, because who dominates the market for microprocessor? Again, Intel. Okay, so by purpose. Yeah. Look, it is doubled almost 2 years. Okay? But how about die size? Oh, hopefully not too much. Okay? Because the larger die size means the less yield. For my analog IC layout class, it is predicted that the yield is reversely proportional to the triple times of area. Okay? And so if you increase the die size by 2, it means the yield will be reduced by 8 times. I mean, for the same technology. Okay? So it's really awful. Yeah. It means what? If you double the chip, I mean with the same technology, 7 nanometer, the same. Okay? If you double it, the chip size, then how about the price? The price will be increased by 8 times? No. By 16 times. Why? Because the yield becomes 1/8. But the chip area is doubled by 2, right? So 8 by 2, totally 16 times. You need to pay for it. So humankind is really afraid to make the die size becomes larger than before. Hopefully not. So you can see the increase in die size, the growth in die size actually is much slower than the number of transistors. Okay? Yeah. So, on average, only 7% increase in die size per year. Okay? Yeah. So it grows only 2 times larger in 10 years. Hopefully, not too much. Good enough. How about the operation frequency? It looks good, but in this era, around 1980s, you can see the frequency stopped. Why? Why we don't go all the way up? Simply because the problem caused by heat. We need to, by heat dissipation, we need to dissipate the heat generated by the chip. But in that era, humankind didn't have good enough technology, to dissipate the power, the heat. So we need to stop there. Stop and think what we can do. And finally, 10 years later, wow, we figure out some new way for heat dissipation. Then the frequency go up again. Okay? Yeah, that is for power dissipation. You can see from less than 1 watt all the way to to how much? 100 watt. You can see, never mind how powerful the chip is according to the physical limitation for power dissipation. 因为要散热的那个物理极限。You can see nowadays for consumer electronics, the maximum power is stopped here, 100 watts and no more. That is not for server. For server, it can go higher. Okay, with very special power dissipation system. It is very luxury, very expensive. No good for customers. Okay, only for companies, just like Google, just like Amazon. Yeah, anyway. For humankind? No. For end users, 终端消费者, 100 watts becomes the upper limit. Okay, that's it. No more than that. All the way. If, anyway. Okay, that is only a ridiculous prediction. We never go there. Unless for server, okay, for desktop, notebook, mobile phone. No, 100. Good enough. If you talk about power density, the power per unit chip area, okay, for example, centimeter squared. Okay, how about the power density? How much watt per centimeter squared you can get from the chip? You can see, wow, from here all the way to the future. Will it be? Let's wait and see. Here, all the way. Oh, during 1980s, according to the power dissipation problem, so we don't push up the operation frequency, okay? The operation frequency stop over there, as I mentioned moments ago, but Intel and the other companies try to reduce the power consumption. With the same performance, but with less power, okay? Then they get good enough experience for such kind of low power design. Again, they push up the frequency to get better performance. So after that, we learn a lot of lessons, experience from such kind of low power design. Then we try to push up the frequency and again the power consumption, power density. How large it is for comparison? Will it go all the way up? No. Why? Because here in about 1995 or 1996, the power density is already as the same as hot plate. You go to a restaurant, they have some kind of hot plate to help you cook in front of you, in front of your faces, right? 铁板烧, to provide you the food. So, in the lab, if your bosses are absent, you can buy some chicken, beef. Open the case of your desktop, right? Put the meat over your CPU. Minutes later, you can enjoy the meat very much. That is in the past. And how about right now? If you go all the way, the power density could be as high as nuclear reactor. You can generate your own power for free, okay? Just attach some power electricity generator to your CPU, then it will help you to generate a lot of power. It's really hot. Okay, if we go further, just like a rocket nozzle to the Mars, forget about it. So it won't be true. As I mentioned, humankind stop at about 100 watts, good enough. No further. Okay? This is some kind of real data for you. For such kind of power density. You can see it is stopped here. no more. Even from 2010 to 2020, the same. Look into the future, I promise you the same. We need to save our Mother Earth. Don't penetrate. Don't break through such kind of upper limit. No. We had better go down in the future. Okay? Through the help of new processes, the newer processes always mean the less power consumption for the same circuit. Okay? Not only microprocessors, you can see, for our cell phone, in the past, our cellular phone actually is really bulky. Yeah. For the first cellular phone here from Zhonghua Dianxin, yeah, the first one, analog cell phone, we call it Black King Kong, 黑金刚, because it's really bulky, very heavy, and really strong. I mean, robust. Till now, I heard that the first Black King Kong is still very popular in Thailand. Why? For such kind of, how can I say, the bad guys, they usually use such kind of Black King Kong only for fun, not for making calls. Then hangover in the street, if they see somebody not so happy, then they use the Black King Kong to break their heads. So even it is not functional, because it's already 20 or 30 years ago. And also, right now we don't have such kind of analog cellular phone system. It is phased out 10 or 20 years ago. So why? What is the final function for Black King Kong? Oh, very simple, for fighting. Yeah. So the bad guys in Taiwan collect all those Black King Kongs, then ship to Thailand for them to fight. We make money, and many of them were injured. That's it. That is a really silly story for such kind of cell phone. Oh, I mean, for cellular phone, actually, you can see the market increase exponentially, but you can see the size stop here, no larger. Okay? That's it. Large enough, good enough. What do we need for new phones? Higher speed, more functionalities, and longer lifespan. I mean for battery. Okay? Usually for you young guys, you use such kind of mobile phone, maybe only for 6 months or 1 year, then you buy a new one. Okay? And for myself, I always got the older ones from my families, from my wife, from my son or daughter. Yeah, if they would like to phase out their phone, then I got it. I got the new one. Oh, from them. Okay, they buy the newest one, and I get the older version. That's it. I'm an old man. I'm old enough. I don't need any kind of fancy stuff. Okay, only what I need from iPhone 9, Messenger, or Google Map. That's it. Okay, I don't need all the others. Oh, this is a very good story for all of you. You can see this is the demand. As I mentioned, we need more functionalities, more power, I mean, in operation, blah, blah, blah. Okay? So that is the demand from end users, from the market. But this is what you can do, I mean, for engineers. We enhance our design capability. You see, the design capability per engineer actually is still increased. Why? Because we learn from our seniors. Okay? You can, if you go back to the future, 100 years ago, what student learned in this class? 0. Why? Oh, our university. Maybe it's only 44 or 45 years old. 100 years ago, here was some kind of rice farm, 稻田, I guess. Okay. If you go to the other places, NTU, that is the Imperial University in Japanese era. 台北地大. Okay. What the student could learn in the class 100 years ago, nothing about chips, no IC design, no IC manufacturing, no telecommunication. Okay. So, based on the knowledge of our seniors, including the professors, okay, including the bosses in the industry, we, just like Newton, we stand on the shoulder of our seniors, so you can learn, you can see further, you can learn better, and this is the reason why if you compare the IQ now and 100 years ago, I promise you about the same. Our evolution is really slow. Okay, don't expect 100 years later, humankind can defeat AI because we become smarter. Okay, about it. Yeah, AI will defeat you. Okay, yeah, the evolution for AI is much, much, much faster than humankind. So, with about the same IQ, why we can produce more? Simply because, again, we stand on the shoulder, over the shoulder of our seniors. We can see further, we can learn faster. That is the reason why. However, the production of engineer is still far behind the demand of end consumers. Okay, so means what? Welcome to join the industry. Okay, you don't need to worry about your future. That is the best industry in Taiwan and also the best industry on earth. It means what? It makes the most profit for the company and for you, engineers, employees. You will make more money than the engineers in the other industry. So again, do join us. Okay? You don't need to join my lab, but you can join the labs of the other IC related professors. This is some kind of technology directions, or we call it roadmap. Okay? 发展蓝图 from SIA. What is SIA? In Taiwanese means passed away. Okay? Semiconductor International Association. Maybe. Okay? 国际半导体协会. You can see that is a roadmap. Here, 0.18 micron to 2014, 35, blah, blah, blah. But to my memory, nothing was correct. Nothing was correct. I mean, if it is predicted by SIA, nothing is correct. Okay? Every year, they need to update their own roadmap. By what? The real evolution is faster than SIA prediction. Okay, that is really amazing and fantastic. You can see, but anyway, the tendency is correct. The exact figures are not correct at all, but the tendency is correct. Feature size means the smaller length or width we can fabricate on the chip. Okay, it becomes smaller, smaller, and smaller. And how about supply voltage? It becomes lower, lower, and lower. Everything. Okay, the tendency is correct. Not only for logic, just like CPU. Okay, DRAM, NAND flash, all of them are scaled down. Okay, the scaling trend for DRAM, for NPU, for VDD is never ended. Okay, this is good for IC layout, but anyway, not so important for you. I mean, for analog IC designers. Okay? Yeah, anyway, I would like to show you, according to process evolution, everything will become smaller than before. That's it. Okay? Yeah, anyway, this is the cost. Even the cost is reduced, but not for the whole chip. I mean, per transistor, the cost per transistor is reduced exponentially or linearly at least. Okay, but don't expect the price for mobile phone will be also reduced. No, forget about it. Because the number of transistors on the mobile phone chip becomes much more than before. Okay, to compensate for such kind of cost reduction tendency, because the number goes in that way. Okay, so it will become flat. That's it. Okay. For a new mobile phone, you always buy it with about the same price compared to the previous version. About the same. And the frequency, anyway. Okay. Again, I need to point out that for operation frequency, MOS is the worst. But why we choose it? Again, the reason is cheaper and less power consumption. Okay, that's it. And why scaling? Simply because for each generation, we reduce the width and length by 30%. So 30% off, it means the area, right, is about 50% of the previous generation. So it means for the same circuit with newer process, the chip size will be scaled down by 50%. That's it. That is our never-ending dream. Okay? But again, the number of transistors, the size of circuit actually is increased. So unluckily enough, the total area for the same chip, for the chip, is about the same. Okay? Maybe you can stop here for another brief break. Anyway, as an engineer, you need to take care of these microscopic issues, 微观的一些标的. For example, you need ultra high speed, very low power dissipation, right? And right now, the interconnect, the metal nice becomes more important than before. You need to deal with such kind of problem. For new processes, I heard from TSMC managers, almost 40 to 50% of the delay right now is caused by wires instead of the circuit itself. You can see how important interconnect is. I mean the metal nice to connect your MOSFETs, your devices. And this is also the reason why the layout team of TSMC is so important. Because the layout team needs to help all its customers to get rid of or to reduce the impact of interconnect before the new process is released to the market. OK， 在还没有上市之前，他们先把新制成的那个连线问题先解决啊，降低它的冲击。Anyway, you still need to deal with the noise, the crosstalk, to increase the enough effect number of bits for your data converters. And also you need to design your circuit to be reliable and also design for manufacturability. Okay. It means what you design, hopefully after fabrication, manufacturing, the yield is not so bad. That is, right now, we focus very much for DFM, design for manufacturability. 你设计的就能够生产了，生产这良率要够高了。 Okay, and how to distribute your clock, because we have so-called clock skew, 时脉歪斜. You need to deal with all such kind of details. It takes a lot of time and effort. However, this is only for engineers. If you are the leader, you are the manager of the R&D team, then you need to focus on such kind of macroscopic issues. You don't need to focus on how to speed up the circuit. No. That is the dirty jobs of your employees. As a leader, as a manager, you only need to focus on this. Time to market, that is very important. Okay, so you need to push, you need to squeeze your employees to work from the day to the night to fit the time to the market. Okay, and also you need to handle the design complexity. If you promise too much to your customers, then your employees, your engineers cannot make it, okay, to get a good time to the market, then you will lose a lot of money. So you not only push your engineers, but also you need to negotiate with your customers. Not too much. Otherwise, we cannot make it. Or you can raise the money, the price sky high, then your employees will be happy to work even in the night. Okay, you need to deal with such kind of clean job. All the dirty jobs here and the clean job here. You need to make the right decision. Blah, blah, blah. Okay, yeah, that is for your reference. So hopefully in the future, you are not only here, but by some years of struggling, kill all the others, okay, defeat all the others, then you can swap to focus on such kind of macroscopic issues. 巨观的，这边是微观的，那边是巨观。That's it. Okay, you can see the complexity. Oh gosh, the staff cost becomes higher and higher, especially right now. According to China, sometimes they would like to hire Taiwanese engineers with the same amount of money, but they change from NT dollars to renminbi. Okay, yeah. Wow. So the real price is 4 to 5 times higher to attract Taiwanese engineers. It's too dangerous for us. Okay, let's have a brief break here.